Okay, let's have some fun. These are fun kind of problems, puzzles. So the question is, here's Faraday's law, and let's make sure that the units work. So the units on the left side are the same as the units on the right side. Now, you may see this and say, that's not Faraday's law. There's no negative sign. There's no n. Okay, cool. I'm cool with that. I mean, n is just how many loops you have. And the negative sign actually doesn't make sense in this form. This is a different rant. But if you have, this is the integral form of Faraday's law, and the negative sign does make sense. But I just want to say that that's there. So let's start over here, and what we want to do is show the units on one side are the same as units on the other. So this side is pretty easy. So we have EMF, and I'm not going to put equal, I'm going to put an arrow. That's in volts, right? That's electromotive force. We want to see if I'm not going to get volts over here. Okay, so I actually want to break this into something else. I want to get it into not the most fundamental units, but at least more fundamental units. So how do you get this into something else? Well, one of the things I like to do is think about an equation that has units in there. So I could say the change in electric potential is the change in energy per unit charge, right? That's one of the definitions of electric potential, and that's electric potential energy. So now I do know that the electric potential energy is in joules, and the charge is in coulombs. So this would be joules per coulomb. I think we'll leave that there for now. That's my left side. Now let's start with the right side. Well, flux. What's the units for flux? You got to know the definition of flux. So magnetic flux is one way. If it's a constant magnetic field at a constant a flat surface, it would be BA cosine theta, where B is the magnetic field, A is the area, and this is the angle between a unit vector perpendicular to the area in the magnetic field. So the first thing is cosine theta. Cosine functions, sine and all trig functions are ratios. They don't have units. So this has no units. I don't even care about that. I'm not caring about numbers. I'm caring about units here. Area, I can do that, right? Area has units of meters squared. That's pretty easy. And then this would be Tesla. But again, what the heck? Tesla, right? The other thing, delta T, has units of seconds. I can deal with that. But what about Tesla? So here's what I'm going to do is to find an equation for the magnetic field. It doesn't matter what equation it is, but I can use that to get an expression for Tesla. So I'm just thinking off the top of my head here, the magnetic field due to a point charge is mu naught over 4 pi QV cross R over R cubed. And now this is a cross product, and these are vectors, but I don't care. All I care is about the units. So this is in units of Tesla. Q is, I know, V I know, R I know. I don't know mu naught. Okay. So now I need another one. I need to find an equation with mu naught so that I can get it. And how about this? How about F, the magnetic force, is this times QV, QVB, right? So it's QV cross B. There. So now this has units of newtons, and that has units of coulombs, meters per second, Tesla. So I can solve this for Tesla, and I get 1 Tesla equals a Newton second per coulomb meter. Not centimeter, coulomb meter. Okay, so now I can put everything in up here. So that's a Tesla. Oh, I didn't even need that. Ha. Okay, good. I didn't want to do that anyway. Okay, so now if I have that as my Tesla, and then I have my area, and then my second. So I can put it all together. So my right-hand side is going to be equal to what's the word? The flux, which is going to be Tesla, which is Newton seconds over coulombs meters, and times meters squared. And then I have divided by the seconds. So then this is going to give me seconds cancel, meters cancel, and I have Newton meter per coulomb. Now, the definition, you see where I'm going here. The definition of work is the F delta R cosine theta. So work is in joules, force is in newtons, meters. So a Newton meter is a joule. Okay, so this is a joule, and I get joules per coulomb And that's the same as that. So, I mean, that's one way to make this connection. There's a lot of ways you could do it. You could break down, I could have broken down joules right here, and I could have broken down newtons into kilogram meter per second squared and all that stuff. But once you get them in the same, you're like reducing both sides until they're the same thing to show that this equation has the correct units. It doesn't show that equation is correct, okay? But if one side has different units than the other side, that's definitely a problem. So there you go. Unit check. Faraday's law. That was fun. Did I not rotate?